Hello guys, welcome to Chi Analysis. In this video, we are going to be solving a calculation on shear force and bending moment for a simply supported beam containing only point loads. We are going to strictly solve the calculations for shear force and bending moment, and in the next video I'm going to show you how to carefully draw the diagrams so we don't rush into things and I do not end up boring you with a long video. So we have this question containing spans of 1.5 meters and 3 point loads. I already solved for the support reactions for this question and I have gotten my answers for RA and RB. I'm not solving for support reaction here because there's a video on that. I made the link to the video available in the description, so please do well to watch it for better understanding. So I have my RA and my RB, and then we're going to dive straight into solving for shear force. Then after shear force, we'll solve for bending moment. One of the things we need to know for solving for shear force and bending moment, first things we want to do is to label our spans. We already have RA and RB. I'm going to take that as points A and point B, and then label the three other spans as C, D, then E. So there we have 5 spans. It's going to make it easier for us to solve. Another thing we need to know is that shear force is simply the sum of all the forces, but we're going to be doing it cumulatively. So we start at the point RA. That shows that we start from the left hand side. Now what I'm going to do in this video, I'm going to solve from the left hand side, then solve from the right hand side, so you can compare both and see why sign convention is actually very necessary. Then again, there's a video on introduction to bending moment and shear force. The sign conventions are clearly explained in that video. The link is also provided in the description, so do well to watch that video also. So diving into shear force, we're shear force at A. Now shear force at a point is equal to the forces at that particular point. So when we're at A, since we're starting from the point A, the force at point A is just one force, that is RA, which is equal to 6.5 kilonewton. That's for A. Now moving on to the next one, which is shear force at C. Now from the beginning point to C, we have two forces, which is that of RA and the force acting directly at C. So we're going to add the both of them. That will give us the shear force at C. That is why I said cumulatively. And then sign convention comes to play in this part. Now when we look at A, the force is acting upwards, which makes it a positive force. Now the force acting at C is acting downwards, which makes it a negative force. So we're going to sum the forces together. We're going to have RA minus the force acting at C, and our RA is 6.5, so we have 6.5 minus 3. That will give us 3.5. Now we'll move on to the next one, which is shear force at D. Now we have the force at RA, the force at C, and the force at D, which is going to make it 6.5 minus 3 minus 6. Now I've already done 6.5 minus 3, which is 3.5. So we just bring down the answer we got at C to D, then we subtract 6 from it. It's simple. We're just trying to compress it so things don't look a bit complex and awkward. So we have 3.5 minus 6 equal to minus 2.5 kilonewton. Then we'll move on to E. Shear force at E minus 2.5 kilonewton minus 5 is equal to minus 7.5. Then the last thing to note is for a simply supported beam, when you are calculating for shear force, the force at the end point, not where you start from, the force at the end point must be equal to 0. Now if I'm starting from the left side, the force at the end point, which is RB, must give me 0. If it doesn't, then it's wrong for a simply supported beam. Now if I'm starting from the right side, the force at RA must give me 0. So that's how we know we're correct. So shear force at B is equal to minus 7.5 plus 7.5 equal to 0 kilonewton. And that's correct. So without wasting time, moving to the right hand side, when we are starting from RB, now sign convention comes to play here also. When we're starting from RB, rather when starting from the right side, RB is now a negative force, no longer a positive force. When you watch the sign conventions video, you understand better. But then we treat forces acting upwards as negative and forces acting downwards as positive. So we have shear force at B is equal to RB, which is equal to minus 7.5 kilonewton. Then we move on to E, which is minus 7.5 plus 5. It gives us minus 2.5 kilonewton. We move on to D, it gives us 3.5. Move on to C, it gives us 6.5. And then finally at A, which will give us what? 0 kilonewton. That's how you know both are what? Correct. So that's all for shear force. Moving on to bending moment. Bending moment is simply force times distance. So for a simply supported beam, bend moment at A and at B is always equal to 0. I've also treated that while resolving support reactions, which is a link in the description. We're just going to treat 3 bending moments, which is at C, at D, and at E. Now bending moment at C is going to be, when we look at C, we're not considering the forces acting at C. We're only considering forces acting before C, which is RA force. So bending moment at C is what? RA times 1.5. It's a clockwise moment. So if you do not understand the concept of bending moment, do well to watch the video concerning resolving support reactions, how to calculate for support reactions. It's better, clearly and fully explained there. We have RA times 1.5, which will give us 6.5 times 1.5, that's 9.75 kilonewton meter. Then we'll move on to bend moment at D. We're going to consider force acting at A and at C, which is 6.5 times the distance from A to D, which is 3 minus 3 times 1.5, which gives us 15 kilonewton meter. Then bend moment at E, we're going to consider forces acting at A, C, and D, which is 6.5 times the distance between A to E, which is 4.5 minus 3 times 3 minus 6 times 1.5 is equal to 11.25 kilonewton meter. So that's how to solve for shear force and bending moment. And in the next video, I'm going to show you how to draw the diagrams for this particular question. So if you like what I did here, if you like the video, please don't forget to give me a thumbs up and subscribe, and also drop your comments. What you do not understand, what you'd like to see next, drop your comments. Let's interact. Thank you.